Good morning everybody, this is another video from Derby Physics Tuition, and I've been working with a student who is studying GCSE Physics, and we've been looking at refraction and one or two demonstrations to make her think a bit more deeply about refraction. And what you can see on the screen is a casserole dish, and it's full of aqua gel beads, which are small beads, and I've soaked them in water so they've absorbed the water. And underneath the dish is a piece of paper with something written on it. Now at the moment we can't see what is written on that piece of paper because it's covered by these aqua gel beads, which, as I said, are basically full of water. I've soaked them in water for about an hour, and they've absorbed all the water. Now what I'm going to do is pour some water into the dish, and you can see now that the water is going into the dish, and when you pour the water in, the word suddenly becomes visible, and obviously the word is refraction. And what we're going to look at is why that happens, why you can't see the word before you pour the water in, and why you can see the word after you've poured the water in. So how can we explain what is going on in this demonstration? Well, to explain it, we need to understand what is meant by refraction. And refraction is the process by which a wave changes speed and sometimes direction upon entering a denser or less dense medium. And in the diagram you can see a ray of light which has entered a glass block, and it's changed direction, and then it emerges from the glass block and changes direction again as it enters the air on the other side of the block. Now why does it change direction? Well, when it enters the glass block it has a greater density. We say it has a greater optical density, which causes it to slow down, and that causes a change in direction. So that is what refraction is, and you can see that in the photograph, in the image displayed on the screen. And we use something called refractive index, and the refractive index is the extent to which light is refracted when it enters a medium, so how much it slows down or speeds up when it enters that medium. And refractive index has no units. Air has a refractive index of 1, water has a refractive index of 1.3, and there are different types of glass, many different types of glass, and they have a refractive index of about 1.5. So what are those numbers telling you? It effectively means that when light travels 1.3 times faster in air than it does in water, and glass has a refractive index of 1.5, and so that means that light travels 1.5 times faster in air than it does in glass. So we need these two bits of information, this idea of refraction and refractive index, to explain the demonstration that we saw earlier on in the video. So what we've got here are two images of what we saw in the video earlier on. Okay, and in the first image at the top left, the dish is full of aqua gel beads and air, so the water hasn't been poured in yet. And the aqua gel beads are effectively water, they're full of water, and they're surrounded by the air, and the beads and the air have a different refractive index, and so the light will change direction by different amounts as it passes through the air and passes through the aqua gel beads. And so because there's different changes of direction, we cannot see what's written on the piece of paper, it just looks blurred. Now in the second image on the bottom left, the water has been poured into the casserole dish, and we can now see the word refraction clearly. So why is that? Well, basically the aqua gel beads are 99% water, and so they have the same refractive index as the surrounding water, and the water in the aqua gel beads change the direction of the light by the same amount, and so now we can see what is written on the piece of paper. And because the aqua gel beads have the same refractive index as the water, they appear invisible. So there's the full explanation as to what you saw earlier on in the video. It really does make you think about refraction quite a lot more deeply. And if you do have any comments or any questions, please do leave them in the comments section below. Thank you very much.